A cell is the simplest unit for making electricity. Now coming to a dry cell, it's a type of electrical battery commonly used for the portable electrical devices. Since it is dry in nature, it doesn't spills, you must have used a dry cell in most of your appliances in day-to-day life. Now going back to the history, it was developed in 1886 by German scientist Karl Hessner after development of wet zinc carbon batteries by George Leclanche in 1866. As we discussed, that a cell is a device used to power electrical circuits. Now it has two terminals, positive and negative. The terminal marked negative is the source of electron. That is, when connected to a circuit, the electrons will start moving from negative terminal towards the positive terminal. And the electrical appliance, or in this diagram as you can see we have used a bulb, it will light up. The flow of current, the direction of flow of current is opposite to the direction of flow of electrons. Over here electrons are shown moving from the negative terminal of the battery towards the positive terminal of the battery. Now let's see what's inside a dry cell. So this is a dry cell. As you know, this part of the cell is the positive terminal. This is marked positive. You can see it over here. It's written positive. Whereas the down part, this part is the negative terminal. You can see over here it is marked as negative. Okay. So now I will open it and I will show you how it is made up of, its construction. So to open it, what you need to do is you need to open this layer. You can see there is a slit. This cover we will open. For that you have to be little cautious. Okay, we will remove this cover. So I have already removed the cover. It is little tedious process. You need help for it. So this is the cover which I have removed. Okay, after that there is a polythene sheet. So I have removed the polythene sheet. So you can see that this is the zinc container. Okay, this is the zinc container and this is the negative terminal. This is the zinc container. After that, this red color tape we have removed, and this is the metal cap. Inside, you know, there is a carbon rod, there is a graphite rod. Okay, this is the metal cap. So we'll remove the metal cap. If you remove the metal cap, you can see the carbon rod over here. This is the carbon rod. Okay, this is the electrode. Okay, and one electrode is this, the cathode, and the negative electrode is the zinc container itself. After that you can even remove this plastic top. Okay, now carbon rod can be pulled slow. So now you can see that we have removed the outer covering of a dry cell and it looks like this from inside. You can see over here that the zinc container itself is the negative cathode or the terminal for the cell, and the positive terminal is the graphite rod inside, which has a metal cap on the top, and electrolyte is filled inside. Now coming to the diagram of a dry cell, let us start from the outer covering. So you can see the outer insulating cover is marked with blue over here. If you open it up, you will find the zinc container which is shown with a light brown color over here. Then electrolyte. The electrolyte is marked with red color in the diagram and it is the paste of NH4Cl and ZnCl2. The positive terminal, the positive electrode, the cathode over here is the carbon rod, which is marked with black color. And the paste of manganese oxide and carbon surrounds the carbon rod. These are the chemical reactions that take place inside a dry cell. First, we'll talk about anode. An oxidation reaction takes place as anode. You can see the solid zinc is becoming Zn2 plus and 2 electrons are given out. And what is happening at the cathode? At cathode, the reaction is NH4 plus MnO2. They're taking 2 electrons and we are getting Mn2O3, H2O and 2NH3 in aqueous form at the cathode. This is the reduction happening at the cathode. Thanks for watching. Do subscribe the channel for more such informative videos.